Quite a while ago, around the time I got the baggage X-ray, I also picked up this. This is a an X-ray machine for screening sort of mail and parcels, that sort of thing. It's got a sort of cabinet in the side. You can sort of stick your sort of moderate size parcel or small bag into, and it's got an output to a standard sort of VGA type monitor. And you hit the button for about 10 seconds. And it produces an X-ray. The resolution is not brilliant on this, but it's quite. You can clearly make out all the details inside that that drill, and the pixel resolution on this sort of one wire is about sort of 2 pixels or so. And one thing I noticed on it, I didn't have any manual or anything, but it's got sort of these prompts on the screen. I couldn't figure out, well, what does that mean? It suggests some sort of user interface. And the only thing on the back, apart from the VGA connector, there's a serial D connector, so I just assumed there was going to be some sort of custom interface or some sort of maybe a foot pedal or something. But just by chance I was looking at the documentation on the camera that I found, and found that it actually takes one of these. Now younger viewers might not actually remember these, but before the days of USB, mice used to have a serial port. And sure enough, if you plug this serial mouse in, you can do some fairly primitive zooming. It doesn't actually give you a huge amount more resolution. It's still fairly pixelated. And just one mouse button cycles through was it times 1, times 2, times 4 and times 8 zoom, and there's some different colour mappings as well, none of which really seem actually all that useful. So I mean, this mouse doesn't really do anything particularly useful. I think the limitation is really the actual fundamental resolution of the hardware. Now the way this works is fairly straightforward. We've got an X-ray source in the top, and if we look inside the cabinet we can just see the window. That's where the X-rays actually come out. And then at the bottom there's this brown thing. This brown is just a sort of plastic top surface. And what we have in here is there's a mirror at 45 degrees there, and a video camera. And in the back there's some control electronics. Apart from reducing the optical path, the other reason for having the video camera passing at right angles is that it can be shielded from the X-rays. I haven't actually looked to see whether there is any actual sort of lead shielding or anything on top of this, but if you have the camera pointing straight up, then you've got the X-rays in the centre, and that will produce some sort of sparkly effects as the X-rays actually affect the centre itself. The X-rays on this aren't that highly penetrative, so not many of them are going to get through here. But I think the main purpose of this mirror is just to shorten the optical path, so you don't just reduce the overall size of the whole unit, and that just looks up at the screen. This is the X-ray fluorescent screen up here, which is in the bottom of the cabinet underneath that brown plastic. Right, now the reason this thing uses a long exposure is to reduce the power of the X-ray source. But what I was sort of expecting was sort of maybe some sort of either a digital camera or an analog camera and some sort of electronics to do the averaging. But in fact, there's actually no video processing electronics that you can see. Basically, the VGA connector actually just goes straight into the camera, as does the mouse connector. So in fact, I had a look online and actually found that this is actually a sort of customizable camera with built-in processing electronics. That the people, you buy the camera and then you write your own software to run on the camera. So obviously what this is doing, it's doing that 10-second integration, whether it's either a long exposure or it may be taking multiple frames and averaging them. So pretty much all the rest of the electronics in here are just really to do with the running the X-ray machine. They've gone to town on the filtering. There's a mains input filter, and then there's a second filter that filters the output. That just powers the monitor. There's another connector here which, if you look at the legends on the PCB, is for a foot switch. And there's camera trigger. Interesting, there's camera setup, so I wonder if that maybe produces a live image for setting up and focusing and so on. And then just the various inputs and output switches. Pretty much every panel on this thing's got a safety interlock switch. And down here you've got this big mains transformer. Now the actual high voltage X-ray transformer is going to be inside the X-ray head at the top. What this is going to be about is voltage regulation, because it needs to maintain a fairly constant high voltage on the X-ray tube, which in practice is, I don't think this feeds it back, but I think basically the idea is they give the transformer in the X-ray box a constant voltage, and it does this using this looks like sort of multi-tap mains transformer, and there's a bunch of relays on this board. So I think what this is going to be doing is monitoring the mains voltage and switching different coils on that transformer based on what the mains voltage is, to give a constant voltage to the X-ray head, so it produces a consistent X-ray spectrum. So on this board there's not a great deal. There's actually a pic on there. 16C74, it's a fairly old generation. Not sure, there's a 99 date code there, so it's probably about 99-ish build date. There's a couple of opto-isolated devices there. Those are maybe doing the mains switching. There's a couple of MOVs, but nothing particularly exciting. There is does seem to have an internal RS-232 port here. That may be for sort of setup and maintenance or something. That seems to be independent of the camera. And the other chip on here is ELN 2803, which is just driving these relays. There's a few, in fact we've got some adjustments here saying voltage and current. That actually, one of these might be driving the filament transformer, because the way you adjust the way you drive an X-ray transformer is you apply constant voltage and then you adjust the filament current to get the beam current that you want. So these, I'm guessing those are probably triacs. Producing spacey switching is also what looks, I think that's a little circuit breaker down there. That'll just be the DC power supply for all this stuff. So not really much exciting in there. I think the most interesting bit's going to be inside that camera. And yeah, I just had a quick poke in that serial port. We do get a little burst of data on power up, so I'll just have a quick look at that, see if there's anything interesting. Right, nothing too exciting here. Just brings up a little menu. Displays exposure time. That's presumably the how long the tube's been run. Sort of presumably it's 3 hours 40 minutes 25 seconds. You can reset that. T displays the temperature. And the other two just read the current, voltage and current while it's running. And turn it on. So I think that's the voltage rating, so that's bouncing up and down a little bit. Do see. Yeah, so this is the current displaying. Actually see it sort of gradually rising up as the filament heats up, and then it's stabilising down about 10, presumably 10 milliamps. So you can see here it starts at 0, then it's sort of gradually creeping up, and then it's going into regulation. It's regulating it there. So V for voltage, and that's sort of dropping as the current's increasing. Don't know whether that's the voltage going into the AC voltage going into the tube, or whether there's actually some feedback. Just have a look at that regulation. I'm just powering it up through this variac just to see the effect of that voltage stabilisation. If I fire it up, seeing that 50, if I turn the mains voltage down, you see that voltage dropping, so it's not regulating dynamically. But if I do another exposure, it's now back to, yeah, it's obviously doing a measurement when it starts, and then setting the relays. So obviously you don't want to have relays clicking in and out all the time while it's running. So that's down to 215. So if I turn it up during that exposure, it's now increasing. But next time I turn it on, it's back down to the 50 odd. So it's just making a measurement, setting the relays for that measurement, and doing one exposure based on the supply voltage. And if I actually just turn this on at a few sort of different voltages, you should be able to see different permutations of relays clicking on. Yeah, I'm gradually increasing the voltage. And see, it's just switching different different transformer windings in to best match the voltage that it wants. It's probably a 1:4 ratio on those or something. And in the top we've got the X-ray generator. This will be the transformer and tube all in a. This will be the transformer and the tube all under oil for both cooling and also for high voltage insulation, because this has got 70 kV on it, so that's rather hard to insulate without using oil. Right, so this is what's inside. It's full of oil for the insulation for the high voltage. Big transformer. This is the main, obviously the main high voltage transformer, and the actual X-ray tube's down here. It's actually surprisingly small. Get a bit of light on it, and it's only maybe sort of 4 inches long, something like that. There's another transformer here, which I think that might perhaps be a filament transformer. There's sort of 2 wires coming off of that, but that's probably also isolated to high voltage. Looks like cork seal for this oil, and there's some ceramic feed-throughs for the connections. On the outside there's a thermal trip, and here on the door they've actually got 3 micro switches, so there's a sort of triple safety interlock. It needs all those 3 switches to be closed, so that obviously that's a major safety issue, and you really can't have the door open while the X-ray source is on. So I think these are all just wired in series. So even if 2 switches fail, you've still got an interlock. And there's a switch cover. All the removable panels on this thing have got micro switch interlocks on them. And as well as the switches, there's also these contacts here. Presumably this makes it harder for people to bypass it. You need a special bypass plug. You can't just wedge something in the switch hole. The thing that does surprise me a little bit is there's only an interlock on the top, so yeah, it's conceivable if this door got really badly bent, it could potentially still make contact at the top and sort of be leaking open at the bottom, but maybe they thought that wasn't a big enough risk. And on the back of this camera we've got these very sexy looking circular connectors, power in, video, control I/O, and the RS-232 interface that the mouse connects to. Let's take a look at this camera. It's got a test date of 2000 on here, March 2000. Fairly simple lens, standard CCTV type lens. The aperture seems to be set fairly closed. It's an f1.4, so I'm not quite sure. I suppose that may be just to get, I wouldn't have thought you need that much depth of field, but maybe the mirror doesn't give you perfect geometry. We've got a centre in there, which I'm guessing is probably a CCD. There's some traces of grease or something on there. And as you probably expect, there's a DSP in here. There's actually some thermal compound just to couple this up to the lid. There's an analog devices, ADSB 2181. 1996 date code. See, there's a sort of stack of 3 PCBs in here, some flex going up to the back connector, and the actual image sensor board on the front. And the equivalent today will probably just have one FPGA in it and not a lot else. But obviously this is sort of 15 odd years old, so it's a bit older technology. This seems to be built on a very solid sort of metal, presumably aluminium chassis. The whole thing sort of feels very thick and rigid. There's sort of piece along the bottom, and there's a front piece obviously for mechanical stability between the mount and where the actual lens is. And a fairly chunky machined back piece as well. So this is not doesn't look like a particularly cheap piece of kit. It's interesting, looks like the front plugs on that way and the next board plugs on that way, so I think the front probably has to come off next. So the front board with there's a Sony driver chip there, there's I'm guessing for something this age that might actually be, I don't know whether that's an analog or a digital output. Right, in this board we've got this big DSP on this side, a few bits of AC series logic. These, I'm sure these will be RAM, more on the other side. Flash memory there for program storage. Some buffers there. This is a 20 megasample per second A to D converter, so this is what's digitising the signal. Right, this next board, this looks like it's going to the video connector. Yeah, this only connects to the video, so this is clearly the video output. So this is probably an optional board, so depending on what sort of outputs they use, they can probably chop and change different board options in here. Got these quite big funky chips here. I'm guessing there's probably some sort of video RAM or field memory type thing. Yeah, this is a 1 megabit triple port DRAM, obviously designed for video applications. There's a couple of Altera CPLD devices there, and a music, which I'm guessing is going to be a video D to A converter, judging by the fact it's right next to the video connector. So that's clearly the the video frame buffer, a little bit of timing control in these CPLDs and the D to A. So that leaves this board, which I can only assume is power. That's about the only thing left. In fact, yes, it actually says POW. Yeah, we've got a couple of packaged DC-DC converters here, covered in heatsink gunk. The heatsink to the bottom, a few capacitors, some opto couplers. So I'm guessing the controller's all opto isolated, which makes sense, and just a few odd little bits of analog. So this is clearly the power thing. So yeah, pretty much as expected. Power supply, analog camera front end, digitizer and DSP, and frame buffer. So yeah, nowadays, yeah, that'll probably all be pretty much in sort of one FPGA, not much bigger than this thing. Obviously, this is back in 1996. This backboard is just purely interface. Just got the connectors, there's a few odd capacitors and stuff in there, but nothing really. There's probably just RF filtering and stuff. There's some those diodes there. I'm sure those would be protection diodes for the I/O connector. But no. And this is an article I found actually when I was looking for information on the camera, and in fact it's the same company that makes that X-ray unit. It's just a slightly different version of it, and it actually gives you a nice complete block diagram of the whole thing. So sort of X-ray generator, target. Interesting, it says there's lead glass here, presumably to stop the X-rays affecting the camera. It even says it's a PIC 16 C74, and this is where I found out that it was a serial mouse. I bought a couple of X-ray cassettes off eBay a while ago just to have a play with. This is the plastic material out of one of these. These are normally used for most film-based X-ray processors, because it just allows you to get images with less X-ray energy. So instead of relying on the effective X-rays on the film, it's sandwiched between two sheets of material that glows under X-ray, so that light helps expose the film. That basically allows you to use less X-rays, but it does reduce the resolution to some extent. For the better resolution, I think they normally use just pure film, but you need a higher X-ray dose to do that. A bit of the material just right over the output of the tube, so this should be more concentrated. So let's see what this looks like. Right, I've just put a small PCB on top of that piece of phosphor material. I'm just zoomed right in. That black blob is just a mark I put to mark the centre of the X-ray tube. Let's see if we can get something that looks vaguely interesting. I'll just put the camera in night shutter mode, which slows down the exposure time. I get a bit more signal from that. I'm fairly sure the resolution of this thing is limited by a sort of fairly big spot size on the tube. I was going to try a few experiments with the SLR, sort of pointing at the X-ray screen and a target at different distances. Obviously if the screen is further away from the target it will produce a bigger image, but I don't think it'll actually give any better detail because of the spot size of the tube itself. One problem with this, you can actually see quite significant speckling from the X-rays on the camera image. So I did a couple of quick tests. This one is with the just the lens pointing straight up with the lens cap on. But then if I actually took the lens off completely, so the sensor was directly at the X-rays, you get rather a lot of noise. These were both 1 second exposures, so I think we need to try and find a better setup. Right, this setup seems to work sort of reasonably well. I figured that if we get the screen right next to what we're trying to take an X-ray of, that should reduce the effect of the spot size to some extent, you casting the a hard shadow directly onto the phosphor. So I just got the piece of that screen material on top of a piece of glass, and then I've got the camera set up with a mirror. This mirror came from an old projector, surface silvered mirror at 90 degrees, which, as well as allowing for shielding, also makes it a damn sight easier to focus because you can actually look through the viewfinder. And then I'll just put just a piece of lead sheet on top to protect the CCD from X-rays. I think it's probably about the best we can get. But the nice thing about this setup is, you know, we can use a completely unmodified cabinet, so we can just use the self-timer on the camera to get the exposure. So that's quite a nice sort of safe method of using it, but also getting better resolution pictures than we do from the inbuilt camera. Obviously one limitation is we are a bit restricted into the size of the target that we can X-ray, but apart from that it seems to work sort of reasonably well. Right, this is a 4-layer board. This is with the shield in place, so there's a few little speckles but not much. I think we need more lead on there. This is exactly the same shot but without the shielding. You see there's a lot more noise speckles in there, so the lead is clearly having an effect. Here's a BGA chip. So the PCB is a QFN, there's a MSOP on there and a few other odds and ends. This is a micro SD to SD card adapter. It looks like it's just a metal stamping. This is a micro SD card. Interesting, you only see some presumably blobs of solder and the rest is just the chippery and so on. There's a DC to DC converter, a QFP package, a larger QFP. I forgot to put the lead on one or two of these shots. This is an NVE RS485 isolator. This is an analog devices isolator that's also got a DC DC converter built in. A little SIP package. This is a just an SO device. And this is a node that's got a large power slug in the bottom, so it's a fairly big chunk of fairly thick metal in the bottom of that. And here's an RFID card and a credit card with chip and RFID. I took a couple of shots of the board from the Flurry 4 thermal imager just to see if I can get some idea of where this connector is tracked to, but I haven't quite got enough resolution to trace the individual tracks. This is the sensor. I didn't really expect to see anything because it's mounted on that magnesium plate, so the X-rays just don't have the power to get through that. All you can see is the bond wires at the edge.